All right, friends, we are going to talk about 5.5, solving quadratics by completing the square. Yep, there's another method to solving quadratics. So we've learned we've talked about graphing, we've talked about factoring. So just a reminder, ooh, come back here, friend. All right, so quadratic equations are that ax squared plus bx equals c equals 0. So when we're solving them, we're trying to figure out what value of x is causing the entire equation to equal 0. So that we really can see when we are looking at, I'm going to move that friend out of the way, graphing, okay? So when we do graphing, we're looking for when that value of x crosses my y-axis, what x gives me an y equals 0, okay? So we graphed those, we can find them. We can do it on our graphing calculator too. We haven't really done that in class. We found our points by hand, which works just great for us. Oh, Smartboard. Okay. And then we also did factoring, okay? So if graphing doesn't work, we could do factoring. So we get it into our terms and we use our ZPP or zero product property and set each of those factors equal to 0. But we found that factoring doesn't always work. So we have this lovely complete the square that we are going to try. So if here's our first problem, we want to not forget that we have our square root property. So this problem here, we can factor into x plus 5 and x minus 5 and set each of those equal to 0. But we have our square root property, so I can add 25 to both sides and get x squared equals 25. Well, to cancel out my square root, or square, I'm going to take the square root on both sides. So we get x equals, and here we throw out that plus and minus 5, which is, you can see here, we'd get x equals negative 5 and x equals positive 5. So same thing. So we want to keep that in mind here. So that's the first problem on your notes. So we're going to solve this one using our square root property. So let's go ahead. And we aren't going to set it equal to 0 like we would have normally. We're going to use our square root property. So we want to factor what's in the red box. So what multiplies to 25 and adds to 10? And it ends up being 5 and 5. Okay, equals 49. So this is different. We don't have it set equal to 0. Okay, but the stuff in the parentheses is the same thing. So I'm going to put a square on the outside. Then, just like before in the previous problem, we take the square root on both sides to cancel that square. And now we have x plus 5 equals the positive and the negative 7. So I'm going to subtract 5 over. And now we have this problem. We really have two problems here. We have negative 5 plus 7, and we have negative 5 minus 7. So this is going to give us our two solutions. We get equals 2, and we get equals negative 12. So using that square root property, we just have to factor what's in the red box. So pause the video and rewind if you need to. Ooh, that was a bright change to go back and catch that again. So let's go ahead and look at this next one. Again, we're going to factor what's in the red box. And this is leading up to complete the square, you guys. Okay, so if we factor that, we get what multiplies to 64 and adds to negative 16. Okay, so that is going to become a negative 8 and a negative 8. Again, same thing in the parentheses. So we're going to move them into 1 and have it squared. So to get rid of that squared, we need to square root both sides. This is that square root property. So we get x minus 8 equals plus or minus 7. So we add 8 to both sides and we get x equals 8 plus or minus 7. Again, here it splits into two problems. So 8 plus 7 and 8 minus 7. So we get 15 and 1. So awesome. Both of those look great. Now those two problems were good. We had nice numbers. I'm going to go ahead and erase this to make a little room for problem 4 to come on out. All right, we're going to do the same thing here. We are going to factor what's in the red box. So what multiplies to a positive 9 and adds to a negative 9? I mean, adds to negative 6. That's negative 3 and negative 3. So I'm just thinking about this. Okay, that's all I was doing with these ones. 64, negative 16. So this is the same thing. So we get x minus 3 squared equals 32. I want to get rid of the square, so I'm going to square root on both sides, and I get x minus 3. Oh, I don't need a parenthesis there. Equals, now 32 is not a perfect square root, so we leave it. Can I factor it down? Let's see here. 4 goes in there, 16 goes in there. That's my bigger one, right? So this becomes, I'm going to take the square root of 16, and that's 4, and then I leave square root of 2 underneath. So it's just simplifying. I looked for my highest perfect square, which was 16, and split it, and then I simplified it. So now I'm going to add 3 to both sides. So my solution is 3 plus or minus 4 times the square root of 2. Now a big no-no is we are not going to add that 4 in the 3 or minus the 3 in the 4 because the square root of 2 is attached to that 4. Think of it kind of like a variable. If you had something that looked like this, you wouldn't be able to add those either, okay? So just a side note there. So this here is an acceptable solution. This is actually the exact solution when you leave it with the radical. If you break it down and use decimal, you are going to get 8.7 and negative 2.7. So those are approximate because they've been rounded. That one is the exact. So we are going to use this idea of the square root property in the thought process of complete the square. So you have to jot down in steps to completing the square. So step 1 says put C on the other side. So pause the video here so you can write that down. So you're going to put C. That's this negative 20. So I'm going to add 20 to the other side. X squared plus 8x. And now I am going to leave a little plus blank here, 20, and I'm going to put a plus blank on this side. Okay, because if you look back at problems 2, 3, and 4, they all were equal to a number this time. All right, step 2, divide b by 2 and square it. So step 2, I'm going to take b, which is my 8, and I'm going to divide it by 2. So that becomes 4. And I square it and I add it to each side so it gets put into those blanks. All right, step 3. It says, oh, there's the add part, sorry. Here's our add b to both sides of each side. Okay, here's the next part. We're gonna factor the left side. So this is that red box from before. We're going to factor that. So what multiplies to 16 and adds to 8? That is going to become x plus 4 and x plus 4. And this equals 36. Come on out. We are going to take the square root of both sides because remember, x plus 4 times x plus 4 becomes x plus 4 squared. So the next step says we take the square root on both sides. So we get x plus 4 equals 36 is a perfect square root, so I get plus or minus 6. And then the last one, if it comes on out, is going to be solve for x. So that means I'm going to subtract 4 over, and I get x equals negative 4 plus or minus 6. So it splits it into two problems, negative 4 plus 6 and negative 4 minus 6. Negative 4 plus 6 gives me 2, and negative 4 minus 6 gives me negative 10. Whew. Okay, pause the video, make sure you can get that all written down, rewind it, watch it again, email me with questions. Here's your first complete the square problem. So let's go ahead and get this one done on the top of page 5, and then I think we're going to just end here. Okay, so it says find the value of c that makes x squared plus 12x plus c a perfect square. Then write the trinomial as a perfect square. So we are looking for what c value makes it a perfect square. So this is where we take half of b, which is 6, and we square it. And then it goes, that's what c becomes. So this is x plus 6 squared, which would be x squared plus 12x plus 36. So this is our trinomial out. Here it is squared. All right, we'll call it a day there, and tomorrow we'll actually crank into completing those square problems when we're face to face. Bye, guys.